Hi everybody, Mrs. Pesic here. We are looking at section 5.5, multiple angle and product to sum formulas. There are 4 other categories of trig identities that we're going to be looking at, that exist, which would be multiple angles, that's like sine of 2u, cosine 2u, sine 3u, and so on. Squares of trig functions like sine squared, half angle formulas like cosine of u over 2, and products of trig functions, like how do you figure out what to do with sine u times cosine v, something like that. In this video, we are only looking at these 2 types, multiple angle and half angle formulas. So let's take a look at what those double angle formulas are all about. We have these double angle formulas. They're often used in calculus, and that is that the sine of 2u, which by the way is not just equal to 2 times the sine of u. You can't just pull the 2 out in front and have it equal this. You have to have 2 times sine u cosine u. And there's actually 3 different formulas that you could use for cosine of 2u. One is cosine squared minus sine squared. Another is 2 cosine squared minus 1. And another is 1 minus 2 sine squared u. And there is a formula for the tangent of 2u, which would be 2 tangent u over 1 minus tangent squared u, but you could also just use sine 2u divided by cosine 2u if you already knew those 2 values. All right, so let's take a look at our first example. For this one, we're solving the equation cosine 2x plus cosine x equals 0. Well, we got 3 different identities to choose from for cosine of 2x, but I think I would probably choose this one because it only has cosines in it, and we also have a cosine already in it. So let's use that one, and that is going to be 2 cosine squared x, minus 1 plus cosine x equals 0. So we're using the 2 cosine squared x minus 1. So in this case, let's rearrange things so we put it in order and then factor. So I've got 2 cosine squared x plus cosine x minus 1 equals 0. And then if I do product sum, the product is negative 2, the sum is 1, so I'm going to use 2 and a negative 1. So this term comes out, and I'm going to replace it with a 2 cosine x and a minus 1 cosine x. So I have 2 cosine squared x plus 2 cosine x minus 1 cosine x minus 1 equals 0. We are factoring by grouping, so I can factor out a 2 cosine x, and I have cosine x plus 1. And here I can factor out a minus 1, and I get cosine x plus 1. So in factored form, this is going to be cosine x plus 1 times 2 cosine x minus 1. I set each of these equal to 0, and I solve. So I have cosine x plus 1 equals 0, which is the same as saying cosine x equals negative 1. And where's the cosine x equal to negative 1? Well, that would be on our unit circle. That's going to be here at pi. And of course, I could keep wrapping around and get back to pi again. So I'm going to say pi plus 2 pi n, where n is any integer. And over here, if I set this one equal to 0, I get 2 cosine x minus 1 equals 0. That's 2 cosine x equals 1. And then divide by 2, and I get cosine x equaling 1/2. All right, and so at this point, where is the cosine equal to 1/2? Well, on our unit circle, that would be here at pi over 3, and here at 5 pi over 3. So I'm going to add to my list of solutions here. I've got x equals pi plus 2 pi n, and I need x equals pi over 3 plus 2 pi n, because I can keep wrapping around and getting back to that same point again, and x equals 5 pi over 3 plus 2 pi n. And again, that means, whoopsie, that means, that's weird. That means we have to add to this all of these solutions where n is any integer. All right, that's our solution for number 1. Let's take a look at our next problem. It says use a double angle formula to rewrite g of x equaling 3 minus 6 sine squared x, then sketch over the interval 0 to 2 pi. So for this one, let's rewrite this as 3 let's factor out a 3. So I'm going to have 3 times 1 minus 2 sine squared x. Well, 1 minus 2 sine squared x is really the same as cosine 2x. That's one of our identities for cosine 2x. And so in this case, we're really going to be writing it like this. And then if we were to graph this, we know that the period is equal to 2 pi over 2, right? 2 pi over b, and b is 2, so that's just pi. And the amplitude is 3. So our graph is going to be, let's say, pi over 4, pi over 2, 3 pi over 4, pi. And instead of it going up to a height of 1, it's going to go down to a depth of -1 and up to a height of pi. I'm sorry, going up to a height of 3 and down to a depth of -3. So my graph is going to start here, cross here, down here, up here, up here. So the graph is going to look something like this. And of course, we could keep going, but that's one period of this function. All right, let's take a look at number 3. It says use sine u equals 3/5, where u is between 0 and pi over 2, to find sine 2u, cosine 2u, and tangent 2u. Well, let's start this one off by drawing a sketch of angle u. We know it's in quadrant 1, and so we're going to draw in our segment into quadrant 1, draw a vertical down to the x-axis, never over to the y-axis. We put a right angle, and here's our angle u. We know that the sine of angle u is 3 over 5, so that means that 3 is the opposite and 5 is the hypotenuse. So here's my 3, here's my 5. I recognize this as a 3, 4, 5 right triangle, so the adjacent side must be 4. So now we want to find sine of 2u. We already know sine of u, but we want to find sine of 2u. So the formula is 2 sine u cosine u. So that's going to be 2 times 3/5
scheduled. Please call extension 1100
times cosine u, and the cosine u is going to be the adjacent over hypotenuse. So that's going to be 4 over 5. So I end up getting, when I multiply this out, I get 24 over 25 as my sine of 2u. All right, and now if I want to find cosine of 2u, pick a formula. There's 3 different ones for you to choose from. I'll just use the one that says 1 minus 2 sine squared u. So that's going to be 1 minus 2 times, sine of u was 3/5, but I need to square that. So I have now 1 minus 2 times 9/25. That's 1 minus 18/25. And I think that would be 25/25 minus 18/25 is going to give me 7/25. All right, and then lastly, we want to find the tangent of 2u. You could use the formula, which is 2 tangent u over 1 minus tangent squared u. And what will we be plugging in for tangent? Well, tangent is opposite over adjacent, so that's 3/4. So I would get 2 times 3/4 over 1 minus 3/4 squared. And when you work that out, we get 6/4 over, I think this turns out to be 7/16. If you work this out, 1 minus 9/16 is 7/16. And so we end up getting, I add this in here, 6/4 times 16 over 7. And it looks like I'm getting 24 over 7 as the tangent 2u. But you could have also done sine of 2u divided by cosine of 2u. And I think you would still end up getting 24 over 7. You can check that if you'd like. All right, let's take a look at the next one. Well, first of all, we have to introduce half-angle formulas. The half-angle formulas are sine of u over 2 equals plus or minus the square root of 1 minus cosine u over 2. And the cosine of u over 2 is plus or minus 1 square root of 1 plus cosine u over 2. So they're the exact same formula, except the sine has a minus and the cosine has a plus. But other than that, they are the same formula. And the tangent of 2u could be either written as 1 minus cosine u over sine u, or sine u over 1 plus cosine u. That's the formula for tangent of u over 2. Note that we see a plus or minus here. we see this plus or minus here, and that plus or minus, we decide on that based on what quadrant, sine of u over 2 is going to be in, what angle u over 2 is going to be in. All right, so let's take a look at an example. If we want to find the exact value of cosine of 105 degrees, that's not on our unit circle. But what we can notice is if we call the 105 our angle u over 2, then if we multiply both sides by 2 to find out what angle u would be, we get u is equal to 210, which is on our unit circle. So we know that 210 is right here on our unit circle, and the order pair here is negative square root of 3 over 2, negative 1/2. So let's use our formula for cosine of u over 2. All right, that's the one with the plus. So we want cosine of 105 degrees is equal to plus or minus the square root of 1 plus cosine of u. Remember, this is u over 2, so our u is going to be the 210 degrees over 2. All right, and should it be positive or negative? Well, 105 degrees, if we look at a unit circle, 105 degrees is definitely in quadrant 2 somewhere, and cosine is negative, sine is positive, so we know we want negative. So this should be a negative square root of 1 plus, what was cosine at 210? It was the negative square root of 3 over 2. And we're going to divide by 2. So we get negative square root of, let's get a common denominator here, 2 over 2 minus square root of 3 over 2, all divided by 2. And that's going to be negative square root of 2 minus square root of 3 over 2, divided by 2 over 1, which we can write as negative square root of 2 minus square root of 3 over 2 times 1 over 2. So we get negative square root of 2 minus square root of 3 over 4, but square root of 4 is just 2. So I get negative square root of 2 minus square root of 3 all over 2 as our answer. All right, and then we have, and we already discussed why it would be negative. Let's take a look at one more example. We're looking at this problem, ignoring air resistance. The range of a projectile fired at an angle theta with the horizontal and with an initial velocity of v sub 0 feet per second is given by r equals,
Please call extension 1100.
r equals 1 over 16 v sub 0 squared sine theta cosine theta. R is the horizontal distance in feet that the projectile will travel, and a place kicker for a football team can kick a football from ground level with an initial velocity of 78 feet per second. At what angle must the player kick the football so that it travels 188 feet? So we're using this formula, r equals 1 over 16 v sub 0, which means the initial velocity squared, times sine theta times cosine theta. Well, first of all, let's try and get this sine theta, cosine theta. Can we just get one trig function in here? So if we could just get a 2 times sine theta, cosine theta, then that's really the same as that's the same as sine 2 theta. But we don't have a 2 sine theta, cosine theta, we got a 1/16. Well, how about this? How about we multiply 2 times 1 over 32, because 2 times 1 over 32 would be the same as 1 over 16, right? And don't forget, we still have this initial velocity squared that we have to have in here as well. So that means we can rewrite this as r equals 1 over 32 times initial velocity squared times sine of 2 theta. Now let's plug in what we're told. The range is 188. We want the projectile to go 188 feet. And this is going to be, the projectile is football. And then 1 equals 1 over 32. The initial velocity is 78 feet per second, which we need to square, times sine of 2 theta. So in this case, let's multiply both sides by 32. When we do that, this divides out with this, and we end up getting 6,016 equals 78 squared times sine of 2 theta. And then if we divide both sides by 78 squared, we're trying to solve for this angle, we get, I think it's like 1 1,504 divided by 1,521 equals sine 2 theta. And now let's use a little substitution here. Let's let u equal 2 theta. And so we get 1,504 over 1,521 equals the sine of u. And that means that u is equal to, this is our equation and we want to solve for u. You know from our work on section 4.7 that that means u is equal to the sine inverse of 1,504 over 1,521. You could get a decimal for that if you'd like. But when you get your angle, it turns out to be 1.42 radians. And if I convert that to degrees, I get u equals 81.43 degrees. All right, but remember, that's equal to 2 theta, because u is equal to 2 theta. So we do need to divide, by 2 here. So we'll end up getting theta equals 40.7 degrees. And keep in mind that that's okay, or its complement would be okay also. So we would also take 49.3 degrees as the complement. So that's the angle at which the player should kick the football, so it's going to travel exactly 188 feet. All right, so that is it for this video on double angles and half angle formulas. Thanks for watching.